right, we're going to get started with exercise 73 today. So if you open up your practice exercise booklets to page 20, exercise 73, finding simple interest. What is the simple interest formula, class? I equals PRT. You're going to get the principal, the amount borrowed, times the rate turned into a decimal, times the time, which has to be in years. Now, you can enter, remember, fractions on your calculator if you wanted to turn the fraction into a decimal, or if you weren't sure. For instance, on here you'll see something along the lines of, let's just say you had 12 and 3/8%. This exact one isn't on there. Well, you could actually type in 12 and 3/8 using the fraction feature, and then percent, I believe, on most of your calculators is a second function, and it would automatically go 0.12375. Or, if you're like, that sounds way too complicated, do 3 divided by 8 on your calculator to get 0.375, and then realize when you move the decimal twice, that'll be 0.12375. So there's a couple ways your calculator can help you with these fractional percents. You're going to do exercise 73. You may begin. Obviously, it'd be even better if you remembered fraction decimal equivalents from olden days. go ahead and put your pencils down. Let's take a look at these together. Quentin was first. Quentin, let's go down the first column, shall we? If you borrowed $15,000 at 9% interest for 7 years, what would you end up paying back in interest?
$9,450.
Good, $9,450 plus the $15,000, of course. You'd have to pay that back as well. That's a whole lot of interest. The next one down, $4,500 borrowed 8.5% interest for just 2 years.
$765.
Good, $765. This next one's more like maybe a credit card or something, putting $500 on the credit card at an 18% interest rate, which is about standard for a credit card, taking just 3 months to pay it back.
$22.50.
Good, $22.50, which doesn't sound awful, but I mean, that's, you know, $22.50 you could have spent on something else if you hadn't had to use a credit card. So that said, if you really, really had to have the $500 thing right then, you pay the $22.50 and you just pay the interest. All right, $875, going down the next column. $875 borrowed at 10.5% interest for 2 months.
$14.70.
Oh, that is not correct. All right, so we go to Genesis. Were you perfect on the first column? You were not. Audrey, perfect on the first column. All right, Audrey, what did you get for the first one on the second column?
$15.31.
It should have been $15.31 there. All right, Audrey, we'll stay with you. $55,000 at a 7.75% interest rate for 15 years. I don't know, maybe this is like an RV or something.
$63,937.50.
Good, $63,937.50. Notice you pay more in interest than you borrowed in the first place. And you do still have to pay back the $55K. You just also pay an additional $63,000. It's a whole lot of money. And then $1,250 borrowed at 6.25% interest for just 6 months. $39.06 is correct. Did you also get them all correct? Okay. I guessed from your response you were correct there. You would have been next in line and you knew it. All right. Questions on any of these? Any of these like, how in the world did you get that? Any questions at all? Anyone get all the ones you did right, even if you didn't finish them all? Okay, Kendall, good. Jamie, good. All right, questions at all? All right. Let me go and collect those from you. And if you would take your homework out, turn in your textbooks to page 181. So we're going to spend the rest of the hour working these unmemorized constructions. You had 4 of them for homework last night. We're going to start by looking at those, see how you did, and then we'll also delve into some new ones today. Again, not so much constructions for the sake of memorizing step by step how to do them, but rather using constructions we've already memorized to complete these, using facts that we know about figures, and putting it all together, using a little bit of common sense to figure out how to finish some of these constructions. The first one you had, you were supposed to construct a right triangle given the 2 legs of the right triangle. So you should have drawn yourself 2 lines, preferably of varying lengths, though technically they did not have to be different lengths. And we'll call this L1 and we'll call this L2 for the 2 legs. I said really the first thing you'll want to do on an unmemorized construction is begin Genesis with a sketch. You're trying to construct a right triangle, so draw a right triangle. And on the sketch, I told you, go ahead and label, Ethan, the things that you have been given. I know leg 1. Now, the way I drew it, by the way, my short leg I drew down here. So I'm going to call this leg 1 and this leg 2. Does it matter? No, not really. But if I want my sketch and my picture to match closely, why not, right? So leg 1 and leg 2. There is one more thing I know, Jamie, that isn't actually on my sketch yet.
Right angle.
I, of course, know the right angle. And so there's 3 different things that I know here. That's really about it. I know nothing about these angles. I know nothing about the hypotenuse. I only know the legs and the right angle. Once I've completed the sketch, Quentin, then we want to start with a long line. And the long line, of course, will serve typically as the base of the construction, though I will hopefully show in just a little bit an example of a long line not drawn as the base. I told you, ideally, along this baseline, pick a point, Chris, that can be our...
like center point. Not center point, but like...
the starting point, right? Pick a point that's going to be the starting point. And it doesn't have to be an end point. It could be. Here I'm going to recommend it not be the actual end point. And this is going to be our starting point. Now, which of the 3 vertices should be my starting point on the sketch?
The right angle, because that's the only one we know.
Certainly this right angle vertex, correct? This should be my starting point. And there's really a couple things we could do here, Chris, to start the construction off.
We could copy the line 2, or line 1 is the base, my bad.
Right, since I said leg 1 is going to be on the baseline, let's go ahead and measure leg 1 and let's put it on the baseline. So we measure and we mark off, here's leg 1, and that's done. All right, then what might we do next, Kendall?
Construct right angle.
Good, we also have right here at this dot, not only does the leg 1 come off the dot, but we also have a right angle at the dot. Now, how do I make a right angle, Kendall?
Do the perpendicular.
Right.
Point.
Construction 4, make a perpendicular at the point. Make a little mark on the short side, make the same size mark over there on the longer side, open the compass a little bit more, make some crisscrossing arcs. And again, this assumes you know these constructions backwards and forwards at this point. You should. We've done them so many times. And and remember this line, I said just make it nice and long, longer than you think you even need it to be. And there we've got our right angle. All right, now what would we need to do, Audrey?
Mark off leg 2 on the left.
Right, leg 2 comes straight up the perpendicular. I couldn't do leg 2 at first because I didn't have the perpendicular. I have the perpendicular, let's do leg 2. Measure it. There we go. And put the point down here, mark it off, and here's leg 2. And now that's done. Well, once you've marked off everything you've been given, it's kind of just a figure out how to finish. Genesis, how do I finish? Because I ain't got a right triangle yet. I've copied everything I was given, but it's not a right triangle yet. What do I need to do?
Connect the arc from leg 2 down to the arc from that leg 1.
Yeah, these are these 2 points, right here and right here, so just connect them. And by just connecting the dots, you've finished your triangle. And there we go. How many had a construction just like this? Excellent. I thought this was a pretty easy one for starters, but wait, sometimes you get something to get the ball rolling here. Questions at all on number 1? All right, number 5, you were doing a right triangle again, this time given the hypotenuse and a leg. So again, a right triangle, but this time given the hypotenuse and 1 leg. Now here, it is important that you draw your 2 lines a specific way. One of these must be longer than the other, class. The hypotenuse. If you did not draw the hypotenuse longer, your construction will be wrong. It has to be, or it will be incomplete, neither of which is a good option. So the hypotenuse must be longer than the leg. How much longer? That actually doesn't matter that much, as long as it's at least a little bit longer. How many did remember to make the hypotenuse longer? All right, questions on that fact? All right, let's go ahead and make our sketch again. We start by sketching a right triangle, and we mark everything we know. First of all, class, we of course know the hypotenuse. We also know one of the legs. Now, I could make either one the leg. Which one's probably strategically the best choice, class? Assuming the baseline is the better leg. And there is one more thing I know, Chris.
Right angle.
I know the right angle. Question, sir.
Yeah. So if you didn't make the hypotenuse, the bigger line is your.
Then your construction is either
It's
wrong
no
or you
leg.
didn't finish it.
Like no.
If you did it correctly, you wouldn't be able to finish. And if you did it incorrectly, then obviously it's wrong. So you would have to. Now again, the saving grace for you guys is quizzes and tests. I'm going to give you the hypotenuse and the leg, and I'm going to tell you which one's which. So for these, you're having to think that through for yourself. But on quizzes, tests, I would tell you this is the hypotenuse, this is the leg, and I wouldn't mix it up. You know, I'm not going to try to trick you. So yeah.
Are you sure?
Yeah, are you sure? Well, I mean, as long as you don't tick me off. I mean, I can always edit the quiz and really just be nice to the teacher and you'll be fine. I like chocolate. Anyway, especially with coconut, peanut butter. Really, any caramel, strawberry.
Do you like the
any
do you
kind of
like the chocolate whip with the cashew cluster?
I guess.
and
All right, questions on this? All right, so we need to start by doing what, Jamie?
By getting a long line.
Drawing a long line. Money's good too, by the way. Money buys chocolate. So.
I did use so much money.
All right. On the line, of course, pick a class
Point.
starting point. And it doesn't have to be a beginning line, certainly could be, but there's my starting point. And on the thing, we need to also pick a starting point. Usually it's this first vertex, right? But doesn't have to be necessarily. Here it certainly would be good to do that. What might we do first here? Kendall?
Do the given leg.
Right, since I put the leg on the baseline, let's go ahead and put the leg on the baseline. Now, if you didn't put the leg on the baseline, you would not have marked off here. You follow what's on your sketch. So if my leg is here, I don't mark the leg off. I would have had to start with something else. But because we put the leg on the baseline, leg, check mark. All right, now what might we do, Chris?
Construct the right angle.
Right, we need the right angle. So again, put another perpendicular here at the starting point. This is what we would have had to do if the leg were not on the baseline. We would have had to start with the right angle. Either one could have been first, in this case, since they both touch that starting point. I definitely can't do the hypotenuse first, though, right? Because it doesn't touch my starting point, unless I put a starting point over here. I mean, this is my starting point. Then I suppose I could have.
Wouldn't that have been harder though?
Probably. And I don't like hard, I like easy. So, there we go. Right angle, done. Now, I would have started with this, and if I put my leg up here, then after I made this perpendicular, I would have measured the leg and marked it off up here. But I didn't put it there, did I? Now, the hypotenuse. Ethan?
I would say connect the dots. Good.
There aren't dots, are there? I do know this dot, right? This point is right there. And this dot, of course, is my starting point, but I don't know up here. But I know the hypotenuse, Ethan, is going to stretch across here somewhere. So that length is going to stretch from here to somewhere over there. How do you suppose we finish?
You could measure the hypotenuse
Certainly, let's measure the hypotenuse. There we go.
and then put it on the line
Put the point of the compass where?
on the second point,
On this second dot right here. Okay, then what?
and then put an arc across the right angle for the leg.
Good. You know the hypotenuse has to have this length. And you know one end has to attach here. You just don't know where the other end attaches. So if you make a nice big arc, or really you don't even need the whole arc, just where the arc crosses here, now you know that line will be exactly this length. And that's when you get that third dot, allowing you to connect these two. And there it is. That's all there is to it. How many had this construction for number 5? All right, if you didn't, questions on number 5.
I have a question.
Yes, sir.
So mine kind of looked like that, but I didn't, like, I guess I still did it wrong, obviously, because I had the hypotenuse smaller than the leg. But I guess just because
Well, you understand if the hypotenuse had been smaller, you'd have been in a real problem, right? Because when you go to measure across,
yeah, I
you
ran
can't
into that, so I ended up just trying to copy the angle that the hypotenuse was connected to at the base.
oh, but this is just a sketch. You don't know what size angle that's supposed to be, so yeah, I definitely don't want to try to follow that. Ethan?
Could you make the hypotenuse the base?
Yeah, I suppose we could. That would give you something like this. In your starting point here, you could mark off the hypotenuse first. Now here's where you'd have just a little bit of trouble.
Yeah, that's what I was thinking.
You don't know what angle to make the leg at, right? So if this is your leg and there's your right angle, notice this line, you know two things. You know the angle at one end and you know the line itself. You'd have actually been better off making your big long line first, pick a point, construct a perpendicular, measure off the leg, and then reach across that. I mean, you could have, this is definitely the easiest way to do it. All right, good question, good. Any other questions? All right, let's turn the page now and take a look at number 14 from your homework, which was not a right triangle. Rather, what were we constructing on number 14? Quentin? I'm sorry?
Isosceles triangle?
Good, an isosceles triangle. What were we given, Quentin, for our isosceles triangle?
Base and one of the base angles.
The base line and one of the base angles. Okay, so we're constructing an isosceles triangle given the base and one base angle. All right, so we should have started by drawing ourselves a line, call it base. I'll just B for short. And then one base angle. Now, does it matter how I make my base angle, class?
Yes, it does.
Yes, it does, Chris. It must be
Acute.
acute. Because what do we remember about base angles of an isosceles triangle, class?
They have to be
They have to be equal. Can you have two right angles?
No.
Two obtuse angles?
No.
So you better have given yourself an acute angle. How many did give yourself an acute angle here? All right, good, because if you didn't, again, you could not do this construction, or at least you couldn't do it correctly. So this is base angle. Now, again, do you see how we had to think through something we already know about an isosceles triangle? Furthermore, although it says given the base and one base angle, really, class, we were given both base angles, weren't we? And that was going to be the key. Let's go and start with our sketch. And on the sketch, we label, of course, the base as being given. And both of our base angles given to us as well, correct? All right, how many identified that? You really knew both base angles. All right, what should we do first here, Jamie?
Draw a big long line.
Certainly, start with a big long line. And we should, of course, should pick a
Point.
pick a starting point, which is going to presumably be this point. Again, I like to start in this bottom left corner. It's just a great place to start. I could start at an end point. Here it wouldn't really matter. It's also not a problem to start further in. My big long line didn't come out very big, did it? It's a really small big long line. Just looking at like, I don't know why. Wow. There we go. Normally I give myself a much longer big long line. Okay, so pick a random starting point. Now, normally I like to come in if I'm going to put a perpendicular. And I don't need a perpendicular, so I don't need to come in on the line at all, but it's not a problem to do that. There's a couple things we could start out with here. Audrey?
Copy the base.
Good. Yeah, copy the base. You know, measure off that baseline and copy it off. And one thing, by the way, I've done this a couple times now. It wouldn't hurt if you wanted to identify other key points. Now I know both ends of the base, right? So maybe marking those might be something, if, especially if you're struggling to think your way through a particular construction, marking those points, you realize now there's only one point left we need. Genesis, now what?
Now we copy the angle.
Then we copy the base angle. And where are we going to put the base angle when we copy it?
Yeah. That's a point. Yeah, I think so. On the point,
Which one?
that one.
This one? There's a better answer, class. Which point?
The other point.
Nope. Both. When you copy it, put it at both points, right? That's going to be key. So when you make this arc, don't just put the arc here and then start measuring, because otherwise you're going to have to do the process all over again. Be smart. Also come here. You're going to have to reverse the compass, right? And cross it over. Then get your measurement. Again, just saves time. I'm lazy. Now, here's where you got to be careful. This is not an arc right here. I'm using a little of each arc. I've got to make sure I measure this way. So I get measure on this arc, and then come to this one and measure this way. And now, when I connect again, not over here to over here. No, this point has this arc going around it, so we're going to connect these two dots here. And when I come over here, I'm going to connect these two dots here. And now do you notice that both base angles have been marked off? Does that make sense? All right, how do I finish the construction though? Because I don't have an isosceles triangle yet. Class? Yeah, and again, remember, this is why I told you in the beginning, make sure we draw the lines nice and long so that we don't have to go back and re-extend them. So I want to make sure they're the right length to start out with. So you can do it all in one step. How many had a construction like this? All right, questions on this one?
This is literally, it was already pretty much done for you.
Yep. All right, let's take a look at number 16. And let's see here. What were we? It was another isosceles triangle, right, Jamie?
Yeah.
What were we given this time?
The base and the leg.
Base and one leg?
The base and the altitude.
Base and the altitude. Base and the altitude on the base. Now, I do want to introduce you to a little bit of notation here. You're given two lines, right? One's going to be the base, which we could label whatever we wanted to. I'll just call it B. The other is the altitude on the base. Now, the altitude can be longer or shorter. If we make it longer, we're going to get a very tall triangle. If we make the altitude shorter, we're going to get a short, squatty triangle. Really doesn't matter. Ethan, tall or squatty?
Tall.
Tall. I had a feeling you'd do that. All right, so we'll make it longer line here. And The altitude is represented by the letter H. You might remember that from your junior high math. Call it the height. Well, the altitude is represented by H. Not A, because A is often used as a side. So we use H for height for altitude, but we're going to use what's called a subnotation. H sub B means the altitude on side B. I'm calling the base B for base. So the altitude would be H sub B, meaning altitude on the base. Because remember, there's 3 altitudes you could draw in a triangle, right? If the sides are A, B, and C, you could draw an altitude on A, H sub A, altitude on B, H sub B, and an altitude on C, H sub C. So here we'll call it B and H sub B. Again, you don't have to notate it that way, but you'll see that notation throughout the rest of this class year, throughout next school year as well. So I wanted you to be familiar with that. I might have made those lines a little longer than I really want them, to be quite frank with you. Let me shorten them up just a little bit for sake of ease. All right, and of course we should go ahead and draw class our
Big long line.
sketch. Before you do big long line sketch. Now, of course, we're going to have an isosceles triangle, so the sides need to be equal to each other, right? We're not given those sides. We're given the base, and we're given the altitude on the base. Make sense? That's it. That's all we're given. Well, let's go ahead and draw our
Big
long line. There we are. See, it's coming. It's coming. Just got to wait for it. And of course, we need to pick a starting point. And this time, I'm going to go ahead and just pick this end point to be my starting point. What should we do now? Audrey? There's really only one good choice. Right. The only line that touches the base that I know, or that touches this point, is the base. So let's measure the base. And once we've measured, of course, we'll mark that off. Again, this is that point. All this is just extra, right? So again, scribbling off excess is fine as well. So I now have my complete base right here. Now here's where we have to think a little bit. What do I know about any altitude class?
It's half of it.
Not necessarily.
It's a perpendicular bisector of the base.
I know that any altitude is going to be perpendicular. That's the definition of altitude, right? Any altitude's perpendicular. But for an isosceles triangle, we said that the perpendicular from the vertex is going to do what to the base?
Bisect the base.
Bisect the base, and by the way, bisect the vertex angle. So it's not just a perpendicular along here, it is the perpendicular bisector because it's an isosceles triangle. If you didn't know isosceles triangle, you wouldn't know that. But because it's isosceles, it's specifically the perpendicular bisector. Again, that requires you to remember something you've learned. But if you remembered that, then we should obviously construct the perpendicular bisector. So remember, let's open your compass more than half, make the arc above and below. Come over here, arc above and below. And when we connect the dots, here's the key. We're going to want to make sure we go up a long way. So yes, I mean, I'm going to connect it starting down here, but I really care more about that which is above. Okay, I don't really care about all that extra line down there, just other than making sure it lines up. So now I know where my altitude on the base is, but I haven't yet marked off the correct length. So obviously, class, now we need to connect what dots?
The point on my end and
This point up here?
no,
Oh, that's just a random, right here.
the base.
Measure the altitude.
Right here. Do
Point
what?
on the
Measure
base.
the altitude.
Measure the altitude. Measure the altitude.
Yeah.
We didn't know how big the altitude is supposed to be, because right, this line just goes up to infinity, right? We specifically need to measure from the base to the top of the altitude. This point is this one, right here. And so now you see, you know all 3 points of the triangle, so now we will just connect the dots. But you had to measure that altitude first. And when you do, you'll get an isosceles triangle with the given base and given altitude on the base. How many had a construction like this? Okay, just a few of you that time. Get questions for those who didn't get it. Does it make sense now? All right, flip back, if you would, to page 181. Now let's take a look at another altitude-y type problem. Number 6. What are we constructing on number 6, Genesis?
Construct the right triangle having given a hypotenuse for altitude on the hypotenuse.
All right, so constructing a right triangle again. Given the hypotenuse and the altitude on the hypotenuse. Now, something that you haven't necessarily learned yet, but I will mention to you, we already know the hypotenuse is the longest side of the triangle. So when you draw your hypotenuse line, make it a good length. Maybe a few inches long. Make it a good length. Now, don't make it so long your compass can't open that far. Depending on your compass, some of you, compass has a rather restricted range. Something you hadn't learned yet necessarily is that the altitude on the hypotenuse has to be less than half the hypotenuse. So you're going to want to kind of eyeball your hypotenuse, estimate half, and go a little bit shorter than that. And this is going to be the altitude on the hypotenuse. Now, the hypotenuse itself is usually labeled C, lowercase c. For those who remember back to your Pythagorean theorem, c squared equals a squared plus b squared, well, c represents the hypotenuse. The altitude on the hypotenuse then would be h sub c for altitude on the hypotenuse. So two lines, a nice long one, maybe a few inches long for hypotenuse, and then less than half is going to be h sub c, the altitude on the hypotenuse. And then we need to draw a sketch. We're trying to construct a right triangle. We know the hypotenuse c, and we also know the altitude. And remember, altitude means perpendicular. H sub c, the altitude on the hypotenuse. And of course, because it's a right triangle, we also know we have a right angle at this vertex. Now, I want to point something out here. Normally, when I draw my big long line, I draw it horizontal. But I don't know anything about this line right here. Last time, we rotated the picture. We could also draw my big long line at an angle approximately where we think the hypotenuse will go. It's up to you. Last time we rotated the picture, how many felt like that worked really well? Just rotate the picture. Let's just do that again. How many say, let's try drawing the line slanted at an angle and kind of make the long line match the picture? All right, let's try that. Go ahead and draw your big long line now, but let's draw it at a slant to represent about where we think the hypotenuse may wind up being. In which case, we're either going to pick this point or this point to be the starting point. Top or bottom? What are you thinking here, Chris? Top. All right, so let's go with this top starting point, and I'm just going to make it this top vertex, this top end right here.
Actually, I regret doing that now.
What?
I regret doing that.
Too late, too late. Let's just go with it. It really did make a difference, to be quite honest. All right, so what should we do from our starting point, class?
Hypotenuse.
Measure the hypotenuse. Mark it off. And this dot is right here. Again, if you wanted to scribble off excess, you certainly could. I've already got 2 out of 3 points of my triangle. All right, so I've constructed the hypotenuse. The only thing left to construct now, class, is the altitude on the hypotenuse. Here's the problem. I don't know where the altitude goes. It is not the perpendicular bisector. If this were an isosceles triangle, it would be the perpendicular bisector. I just know the altitude is perpendicular. I don't know where. So, since we don't know where, and we could put it anywhere, we could put it, for now, perpendicular bisector. Let's do that. let's go and make the perpendicular bisector, recognizing this may not be the correct place for the altitude. But instead, we're going to use a locus to guide our thinking. Because the altitude is a particular distance by virtue of the fact that it's perpendicular, right? So if I could take this particular distance, you realize anywhere along this line parallel to the hypotenuse, this given distance away on either side could be any of the places where my altitude's endpoint could wind up. Does that make sense? So we're going to construct not necessarily the altitude, but a locus showing where the altitude could be. So when you draw this line, again, you're not necessarily drawing the altitude, you're simply giving yourself a perpendicular to measure. Now, technically, we could put the altitude on either side, but we're basing off our sketch. We want the altitude to come down, correct? So I'm only going to measure down. The altitude is probably not this line, but it will fall somewhere along a line parallel right here. How would I make a parallel right here?
Measure the angle.
I wonder, what angle?
The one.
This right angle right here? You could, or you could just make another perpendicular. So now let's make another perpendicular out here at this distance. But draw it like, because it is a locus, draw it dotted or dashed. Because I don't know which of these points is actually going to be my altitude. It's one of them. Somewhere along here is this point. Does that make sense? Do we see what we're doing here? Every construction so far, it's been exactly clear. This is where my line goes. For the first time, I don't know where my line goes. It goes somewhere along this line. Does that make sense? Okay. So, how do I find this point? Well, there's one more key information that I haven't used yet. I have to have what else in my right triangle?
Right angle.
The right angle. But I don't know where to put it, so I can't just make a perpendicular, right? I can't just be like, well, let's make a perpendicular here. Well, I don't know that these points are going to form a perpendicular, right?
Something we can do with arcs.
What do you mean arcs?
Well, the line that we drew is, we said it was perpendicular bisectors, correct?
Right.
And if something bisects between the two, what has,
Right.
doesn't it have to be a right angle?
Does what have to be a right angle?
Since it cuts it straight down the middle.
Well, right here, yes. I mean, we're going to have right angles here
And the definition of a right angle is when two straight lines intersect.
to form equal adjacent angles. But I need a right angle way out here somewhere. So somewhere over here needs to be a right angle. In fact, the right angle needs to be somewhere along this line. I just don't know where. I mentioned it yesterday. When you need a right angle, but it's not on this line, it's off the line. You can always get a right angle if you have a semicircle. And this is why I encouraged you to do a perpendicular bisector. Because if I have a bisector, I can easily make a semicircle. Let's do that. Take your compass, measure from this midpoint out here to either of these ends. Doesn't really matter which one, it should be the same. And give yourself a semicircle. Now we know, class, that any point along the semicircle, doesn't matter which point, if I pick any random point and connect to the ends, I'm going to get a right angle, correct? But I also know wherever I pick needs to fall somewhere along this line. Well, if that's true, there are two possible places where the semicircle locus intersects this parallel line locus. I could either go here and connect the dots, and I would have the perfect altitude and perfect right angle, or I could pick this one. This one matches the picture more closely. Let's go with the lower point of intersection. Connect down to this point. Get that a little bit more precise. It's a little bit off here. And here we've got a perfect right angle, and if you were to actually draw this altitude, it would be exactly the right size. And this construction used a couple of loci to help us think through this, which is why we talked about loci before we got to these unmemorized constructions. And we're going to have to start using more of these ideas of, well, I don't know where this line goes, but I know it's got to be somewhere along here. I don't know where this is going to be, but I know it's somewhere along here. And if you get enough somewhere along here's, they'll intersect. And where they intersect, we draw. Now you understand, had my altitude been greater than half, I could never have gotten an intersection, could I? Which is almost a way of showing that, yeah, the altitude has to be less than half the length of the hypotenuse. All right, let's move on. Flip the page. Let's go back to isosceles triangles now. Let's go back to isosceles triangles now. And let's take a look at number 13. Number 13. We're going to construct now an isosceles triangle given the base and one leg. Let's do it this way. Let's make a decently long line as our base. And then let's go with a slightly shorter line, just slightly shorter line, and call it leg. Slightly shorter line, call it leg. Now, I know this because I'm the geometry teacher. You may have figured it out as well, perhaps, but if you have a shorter leg than you have base, your isosceles triangle is going to be short and squatty. So we're going to have a short squatty isosceles triangle as opposed to a tall one. We did tall last time, so we'll do short squatty this time. Draw your quick sketch. You know, of course, the base, and you know one leg. Fact check.
You know one leg, you know the other.
You know both legs. Good. If you know one leg, you know the other. So technically, it's partly false. Right? If you know one leg, you know both legs. So really,
You know angles too, don't we?
I know them both. I have no clue about angles, but I do know both of the legs.
Well, we know that the angles would have to be equal.
I do know both of these angles would be equal, but since I don't know either, since I don't know this one, I also don't know the other. So I know neither of those. I also know nothing about the vertex angle, except I suppose it's possibly an obtuse-ish angle, since the legs are a little bit shorter and squatty, but I don't know that for sure.
We have everything. Don't we just have to draw the lines? Because we already have the 3 lines we need to complete the triangle, don't we?
Yep, we know all 3 lengths,
So we
just have to construct it. So let's start class with a
Big long
big
line.
long line, and let's pick a
Short point.
starting point. Again, since I'm not making a perpendicular, I could choose an end point to be my starting point. No reason not to. From the starting point, we could perhaps measure the base. We could start with a leg, but since the legs are going to be equal, I'd rather start with the base and do both equal legs back to back. Let's measure the base and mark it off. Base. I now know both ends of the base. Now what? Measure the leg, okay. But
I don't know the angle to put it at.
I don't know the angle to put it at. You're right. Like, where is the leg? Like, I know the leg has to attach to this point, right?
Why don't we just draw an acute angle?
Oh, no. Because now you're making up stuff. That sounds like the Democrats and their impeachment. You know, well, according to reports.
So why is that false?
Because you can't. Are reports all verified true? No. If I just make an acute angle, well, according to reports, it's going to be an acute angle anyway. Well, how do you know what size acute angle it is? No. We don't do anything that's not perfectly logically
We know they have
sound.
to be equal. We know they have to be equal.
I know they have to both be acute, but I don't know how acute. Are they really little bitty acute? Are they big acute? Big? How big? I don't know. Ethan?
Could you measure the leg and put the point and compass on one of the points and make an arc? I did the same thing in yoga.
Yeah, you know that the leg has to attach down here, right? You just don't know where in this locus the vertex is, because it's this given distance from this given point, isn't it? But this same given distance will also be from the other given point. And where the two loci intersect, class, that's where the vertex has to be. And so if you simply connect down, you've got your triangle. We didn't have to make up anything at all.
Take full credit for that one.
Questions on this? And there's your two legs. And the construction's done. Really, it's a side triangle, construction 6, right? But do you understand that really that construction hinges upon loci? Right? Questions on this one? Let's take a look at another one. Let's look at number 15. This is a fun one. We want another isosceles triangle. And again, we're going to be given the base, but this time we're given the base and
The vertex angle.
the vertex angle. Now, you can choose any angle you want for your vertex angle. We could go obtuse, we could go acute. Let's ask, Kendall, are you the youngest in the class? Or is Audrey younger? You're younger by like 3 days, right? Something like that. Okay, remember y'all say, okay, so we're gonna let the baby of the class pick. Acute, right, or obtuse? Acute. All right, so let's go with acute angle here. Let's not go too tiny of an acute angle. It'll make the construction harder. And let's call this vertex angle. And give yourself a line. It doesn't have to be huge. Call it base.
Big long line.
And let's go ahead and
Big long line.
let's draw our sketch. Now, when you draw your sketch, make sure you make the top angle acute, because this angle we are given, and this side we are given. And here's the challenge. They don't touch.
Could you make the vertex angle at the, like make your big long line and then make the vertex angle at the base?
So your suggestion is, why not rotate the picture backward? Make these two be the equal sides, this be your base, and this be the vertex angle. Is this the suggestion? Okay.
That would work.
Let's think through what we would do, right? We draw a big long line, and at one end we measure off the angle, and we have a great big angle, right? How do we know where to put the base?
Is there a way to do it?
I don't think so.
Yeah, I don't know that's going to work. But if we don't take Ethan's suggestion, well, obviously we do it this way, right? We make our big long line, we mark the base off, and where in blazes do we put the vertex angle? But, Ethan, your way, we know the starting point, and that's the only point we know. If we do it this way, and we measure off the base, we know 2 points. 2 points is better than 1 point, would we not agree? Right? So better to hit the shot than just to get fouled and hit one free throw. I don't know. So let's go ahead and draw the base. That's it, assuming you can hit a free throw. Let's go ahead and draw our big long line. And of course, we'll measure off the base. We all saw this part coming, much like the slam a moment ago. All right, and this is what we do, right? All right. We could scribble off the excess, but what in the world do we do with the vertex angle? Well, here's where we have to think back. What do we know about this figure? What do we know, for instance, about the vertex angle?
It's cute. It was cute.
Well, that's only because Kendall chose to make it a cube, because she could have made it
That's the
whatever.
perpendicular bisector. Like, could we make an altitude?
Okay, we do know that the angle, that this point has to lie somewhere along the perpendicular bisector. That would be a locus for us. Let's do it. Let's take Ethan's suggestion. So let's open the compass more than half, make arcs above and below. Brecken, you are dismissed. Whew, just barely got anything there. But draw it dotted, remember. This is not part of your construction per se. Okay, this isn't part of the picture. It's just a locus. But we do know that the top of the triangle has got to be somewhere along that point. But where?
Well, now we can measure the angle, can we?
Well, we could, but like, do you put it here, 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 here? Like, no. What in the world?
Well, I don't see how this is going to work when we have right angles now.
You're right. We do have right angles now. That's an interesting point you bring up. Also interesting that
It's a right triangle.
if you were to draw this, you would form a couple of right triangles. So that what's true about this little piece of angle? It's going to be what?
Half the vertex angle?
It's going to be half the vertex angle, right? So really, if we were to copy half the vertex angle, but where do you put it? How do you know where exactly is the right place? What else do we know about this angle or this half of the angle? Either one. What else do we know?
It's opposite the base.
Yeah, obviously.
Oh, it's adjacent? No, it's not adjacent. Never mind. That's...
Let me ask you this. In any triangle, what do we know about all three angles?
They equal 180.
They equal a straight angle. Do this with me. Extend the baseline of your vertex angle through its own vertex. So if this angle is the vertex angle, what's this, class?
The opposite. It's the,
This is both base angles, isn't it?
Measure it.
Do what with it if I measure it? It's both base angles. Bisected, because what do I know about both base angles? They're equal. So in other words, I'm giving you this angle, but you cannot construct that angle. But you can use that angle to get this one. Does that make sense? And we've already done a construction like that. Let's bisect the extension here. And when we do, we now have both base angles. And now we can construct those. Sometimes you don't actually construct all that's given because, frankly, as in this case, you just can't. But you can use what you're given to construct something else. And I can make a base angle. Now, that doesn't mean to say that Ethan's line is totally pointless. Rather than making both base angles this time, I only need to make one. Because I know that when I copy just this one, it will hit my perpendicular bisector. And wherever it does, that's the top. The other way would be if I didn't draw Ethan's line, I just do both base angles and they meet up. But this way, because I took the time to do perpendicular bisector, I saved myself the second step. And there we go. One extra credit problem tonight is number 21 on page 182. Number 21 on page 182 is extra credit. Have a wonderful rest of your day. You are dismissed.